Right, so Globebusters had a show last night, all about the incoherent dielectric acceleration. I didn't watch it last night. It was on pretty late for me. I was busy doing stuff anyway, and I watched it first thing this morning. And that's probably a good thing because then I don't get blocked in chat for being a troll just because I disagree with him. But what I'm going to do, I'm going to take 3 or 4 bits of pieces that Bob says, and I'm going to show the 3 fatal flaws. If you think that incoherent dielectric acceleration is a thing, then you're going to have to explain these fundamental fatal flaws, because all 3 of them, and any one of them in isolation, stop it. Bob knows better. He starts off by talking about how this is within the confines of his model. That does 2 great things. It gets rid of the trolls, because the trolls can't obviously have an argument within flat earth models, because it's outside of their paradigm. He's not trying to debunk the globe earth. The globe earth doesn't have any explanations for this within their model, because they don't have any electricity or current or voltages or whatever influencing this downwards perception of bias. So that's a brilliant move. But it also causes the problem of reification, because if you're going to then create your model within the paradigm of your model, then it might make sense within your model, but does it work in real world? So let's have a listen to what he says, and just think about reification as he says it.
We're saying that, first of all, you have to look at it from within the confines of a flat earth model. And within the confines of a flat earth model, it is our proposition that what we are dealing with here is we are dealing with the earth as one plate of a giant capacitor, right? So if you know what a capacitor is, it's basically 2 plates that are separated by a dielectric, or usually something that is non-conductive, and then a charge is applied to each side of those conductive plates, right? And what it does is it causes the positive charge to attract to the negative charge, and the capacitor then is able to charge a huge amount of electrostatic potential. All right, notice I said electrostatic potential. So we're saying the same thing is essentially what is happening here on the flat earth model, and that the earth is one plate essentially, and the firmament, which, if you haven't...
Okay, so I've got Bob's words written down so that we can go through them. I'll deal with the main point he says first. He says that he says, notice that I say electrostatic charge, not electromagnetic. Obviously, he's referencing the video I released yesterday, and I'll address that now. Bob's position has been convoluted from day one. I've listened to him at different points throughout his journey, and obviously we're both on the same kind of path. But I've heard him referring to incoherent dielectric magnetism. I've heard him talking about magnetism and electricity essentially being the same thing. So in the past, I've heard him referring to magnetics or magnetism. So I accept that yesterday's video may not have referenced electrostatic electricity and charge. And that's based on my own ignorance, because Bob's position's changed over time, and I've heard him say different things at different points in time, and his position's changed from what I last heard him say. Also, it's the inability to coherently explain your position makes it difficult to understand where you're coming from, Bob. So I'll accept that a little bit of my side and say that I didn't realize that you were talking about electrostatic charge. I thought you were talking about electromagnetic, because I understood your position to be that charge potential and charge flow current was essentially the same as magnetism, because I thought you'd got that from Ken Wheeler. Now, if that's changed, then okay, I can accept that I might have misapplied something there. But you've got to also accept that your position's changed over time too. And the last time I heard you talking about this, magnetism was the thing that you were talking about, and ferrocells and all that kind of stuff. So there's just been a bit of a gap in between your position and my position, and for which I can apologise. If I got it wrong yesterday because your position's changed and I didn't know about it, that's my bad. I should have been a little bit less ignorant, and I should have been more savvy, but obviously time's passed. Now, let's deal with the 2 points he says. Number 1, the Earth as a plate. So he says, if we imagine the Earth as a plate of a capacitor, this is within the confines of his model, remember. If we imagine the Earth as a plate of a capacitor, he defines it as 2 plates separated by a dielectric. He doesn't say the word divide. I had to put that in because he went off on a tangent. With a charge each side. And then he says it causes the positive charge to attract to the negative charge, and electrostatic potential results. All right, so let's have a little look at what Bob's referring to. We've got a very simple diagram to demonstrate what Bob's talking about, and it's in the wrong orientation, so I will turn it round so that you can see it in the orientation that makes the most sense to get the flow that Bob's referring to. Bob's referring to the sky being positively charged with a load of positive ions, and we know that that's true. But for this to work, for Bob's model to work, Bob needs to create a flow. He needs to create an energy flow. Now, to do that, he puts a negative charge to the Earth. The Earth's not a negative charge. If you Google it, initially, when you superficially scratch the surface, you'll find that the Earth does seem to be a negative charge. But it's not actually true. You've got to have some understanding of electricity, right? I'm not an electrician, but I do know how electrics work. And I understand how the flow works, the current flow works. And I think there's a bit of an ignorance here, partly because of we've got a little bit of knowledge, a little bit extra knowledge that the Americans don't have when it comes to wiring a plug, which I will come to in a sec. But the error that Bob makes here that's fundamental is that he's got a negative charge ascribed to the Earth. Well, we know that positives and negatives attract each other. But if that was the case, then there would be no static charge up there, because it would all be attracted to the Earth and there wouldn't be any formulation or accumulation of static charge, but there is. Now, if Bob says, well, that's because of the distance, it's too far away, it doesn't matter. If there's a negative charge, that's an attraction and it will create a flow, right? But there isn't a flow. That's why it's called static, because it's not flowing, static being the opposite of flow. So static electricity or statically charged ions, or whatever you want to call that potential up there, is called static for a reason, and it's because it's not flowing. So there's charged particles up there buzzing around like a cloud, but because it's not flowing anywhere, it means that the Earth cannot and is not a negatively charged force of attraction that is what's needed to create a flow. So Bob's ascribed a negative charge to the Earth, and that's wrong, because the Earth's not negatively charged. How do I know that? Well, it's demonstrable. But if you look at a plug, let's have a little look at a plug. In the UK, we've got 3-pin plugs. We've got the hot wire going in on the right. We've got the neutral on the left. And that's familiar with you guys. But we've got Earth as well. And what the Earth does, the Earth is essentially it's like a shock absorber. So if the device fails, or the electrician that's putting the circuit together makes a mistake, rather than the human absorbing all of the current, because we use 13 amp fuses most of the time, but we use 240 volts of alternating current, whereas you guys use 120. So we use 230, 240, you guys use 120, as far as I'm aware, and that's significantly different. So we need an extra layer of protection so that the human doesn't absorb it all. So let's look on Wikipedia to see what it says, and this is the bit that Bob doesn't get, and this is the bit that thwarts is flow, because if there's no flow, then there's no incoherent dielectric acceleration, because he needs the flow. So let's see what it says about, and this is true. This is real world. When we have the plug and we know how this works because we understand the flow. But Bob doesn't have the plug. Bob's just got a hot and a return, or a hot and a neutral. So because he doesn't have the Earth, he doesn't understand what actually happens here, and this is why he's arguing this position ignorantly. I've been ignorant before, and because I didn't know Bob's position had changed. Now I can accept that I was ignorant. So let's see if Bob does the same with his ignorance and see whether or not he accepts this. It says, and I'll read from Wikipedia, it just says, in electrical engineering, ground or earth is the reference point in an electrical circuit from which voltages are measured, a common return path for electric current. There you go, a common return path for electric current, or a direct physical connection to earth. Electrical circuits may be connected to the ground for several reasons. Exposed conductive parts of electrical equipment are connected to ground so that failures of internal insulation, which create dangerous voltages on parts, which could be a shock hazard, will trigger protective mechanisms in the circuit, such as fuses or circuit breakers, which turn off the power. In electrical power distribution systems, a protective earth conductor is essentially part of the safety provided by the earthing system. Notice it says conductor, not inductor, conductor. So if you put power to it, it will pass the current, but it's not inducting, it's not acting like a mast of attraction of foot. It's not the negative that he needs it to be to create the flow that gives him the downward bias. It will pass current, but it's not attracting it. Now, if it was attracting it, it would mean that the plug that we wire up in the UK would essentially become a spark plug inside a car, because look at where the live is. The live's just right next to it. And if you put in a high amount, remember that electricity is drawn from the appliance, right? It doesn't feed the whole 13 amps that goes in, the whole 230, 240 alternating currents. It doesn't feed all of that into the device. The device takes from it. So it's providing way more voltage and power and current and flow than what the device needs. So look at the way the plug is lined up. If it was a negative attractive force, then look at its proximity to the live going in. The live is right next to it, and there is the ability for it to jump the gap like a spark plug. Electricity will find the path of least resistance, and if you've got a negative charge, that's basically male and female, hot and cold. It's entropy, it's demanding, it's saying, look guys, I can attract all of your charge potential, your current. It's putting up a flag saying this is where you want to discharge to. So it becomes a spark plug, right? If the earth is a negative, the way Bob puts it, but it's not. So let's carry on reading. It says so look at what it says. Connection to ground also limits the buildup of static electricity, right? There's the key bit, Bob. Connection to ground, which the sky isn't connected to ground, is it? It's independent, it's separate. Connection to ground also limits the buildup of static electricity when handling flammable products or electrostatic sensitive devices. Computers, in some telegraph and power transmission circuits, the earth itself can be used as one conductor of the circuit. Notice it says conductor. Saving the cost of installing a separate return conductor. So, what this means is the earth will take the current if you present it, but there needs to be a mechanism for you to present it. And because it's not negatively charged, there isn't the flow that's required to get it. So, how do we know this in real world? Well, electrical storms, we see lightning. Now, lightning goes both ways. Sometimes it goes up, sometimes it goes down. But that's the point. When you see lightning, that's because the sky's getting full of positively charged energy. It's building up over time, but it hasn't got a flow. It needs an arc to get out of there because it's building up too much energy, and eventually it's going to jump the gap like a spark plug. Look at the gaps involved in however high the lightning is. Look at the size of the gap. So the gap goes from the clouds, or wherever it originates from, which will be the center of the collection of the positively charged ions, and down to the ground, or vice versa. But the gap, the distance is irrelevant because you see lightning, and that is the point where positively charged ions meet the negatively charged ions, or the power gets that much that there becomes basically the potential to create the circuit. Because there's that much charge, it becomes close enough to jump the gap. That's what it is. But that process proves that Earth's not negative, the way Bob's got in his picture. So that stops the current flow. It means that there isn't a current flow, and that is the reason why it's called static, because it's not flowing. So this debunks the idea that there is a flow. There isn't a flow coming out the sky. If there was, there wouldn't be a buildup of static electricity or static charge in the sky, and it wouldn't be called static, it would be called flow. It would be called the magnetic flow or the electromagnetic flow or the power flow or whatever. But we don't have that, do we? We have statically building up charge that doesn't go anywhere. So this destroys Bob's argument that essentially there is a flow. Because if Bob creates a flow, then he gets the vector that he wants because he believes in gravity or whatever he calls gravity. But he's trying to do that by falsely representing the Earth to be negatively charged, and it's not. Any electrician will tell you that it's not. It will conduct electricity, but it doesn't induce it unless the charge potential jumps the gap. So, and that's what we see with lightning. So this debunks the claim that there is a flow, because there isn't a flow. Bob needs a current, there isn't the negative attraction, there isn't the flow. So we don't have the bias that he claims. So that stops his argument. And that is still, remember, this is within Bob's model. So within Bob's model, he's claiming that the Earth's negative. But within the real world, the Earth's not negative. It's neutral. There are times when it becomes negative. There are times when it becomes positive. We see lightning go both ways. But generally speaking, for 99% of the time, Earth is charge resistant. It doesn't have a charge. That debunks the claim that there is a downwards flow. Now, because we have the plug, and let's just go back to the gravimeter, the Wikipedia entry, because this last sentence is the bit that nails it. So even if Bob disagrees with everything I've just said, let's apply what it says here. For measurement purposes, the Earth serves as a reasonably constant potential reference against which other potentials, static electricity in the sky, can be measured. An electrical ground system should have an appropriate current carrying capacity to serve as an adequate zero voltage reference level. In electronic circuit theory, a ground is usually idealized as an infinite source or sink for charge, so that's like the shock absorber, which can absorb an unlimited amount of current without changing its potential. That's the bit that stops the electrician getting shocked and killed, because it absorbs the bulk of the current. The human will still get the current from the plug, but not all of it, because the Earth takes most of it away. Now, this proves that the Earth will take the current if it's presented, but it needs to be presented. There needs to be a mechanism to present it, and there isn't one. If there was, it would be a flow, and it would be negative, because the negative would create the attractive force that is what attracts the ions, the positively charged ions. But because they don't get attracted and they build up instead, eventually it arcs out in the form of lightning, because there's enough charge there to jump the gap. But the fact that it does that means that basically Bob's wrong. There isn't a downwards flow. It's nonsense. But I think that might be because Bob doesn't realise what the ground wire does, the earth wire. He thinks that it's a negative because he sees it in a plug, maybe. Because I can understand. If Bob was honest and he said, well, it's because in a plug we've got positive and negative. Well, in England we have positive, negative and earth. And when you realise what the earth does, you realise that the negative isn't the negative. See, it's misleading, because the negative isn't really negative. It's just that it's the neutral, the return. It's just the other part of the circuit, the return that goes back to the next device or whatever. But it's the most important thing to note is it's not a negative. If it was a negative, then we wouldn't have static electricity, would we? Anyway, this basically concludes that there is no downwards acceleration or bias, because there is no flow, because the Earth's not negative. Now, only in Bob's little model is it negative. So Bob can argue that that's how it works in his model. Well, that's the same as arguing that, well, in the ball Earth model, that if the centre of mass is causing an attractive force within their model, that makes perfect sense and it works. But is it the same in real world? No. So within Bob's model, it works, but in real world, it doesn't work. So Bob's doing the exact same thing that the ball earthers are doing. He's reifying into existence a model that doesn't actually match real world. But in the model, it seems to work because he's got a negative charge to the Earth, but in real world, it does not. And this debunks it. This literally debunks it. Now, let's play the next part, because he references gravimeters. And what we're gonna see now is how he makes the claim that this debunks relative density, and I'll show that's not true, and then we'll see how Bob ends up shooting himself in the foot. For there to be a current and a flow, like we've just discussed that there's not one, but Bob wants one and needs one, he's then got to argue that gas molecules will pool on the bottom of a vacuum chamber. Now, we know that gas molecules conserve momentum. They bounce off the walls of the container with elastic collisions with no net reduction in force, and Bob's about to argue that they slow down over time. That means they fail to conserve momentum, and that doesn't happen. I don't know why he thinks this, but this is the paradox that Bob's pushed into. He has to argue this if he's going to argue that the Earth is negatively charged and there's a current, because he needs gas molecules to be pulled down, right? Because it's fundamental to the point that gravity is not a force. And if he can argue that gas molecules are pulled down, then this supports his argument. But we know that gas molecules don't pull down, because we're going to show the bromine video. So just listen to what Bob says now, and then listen to the response by what's his name, Savage. You can tell by John's response that he this is nonsense.
Bit better. But essentially, let me just kind of explain it of how it's working. All right. So in a nutshell, what's happening is you have this device right here. This is the gravimeter. And what it does is it has inside of it a laser interferometer. Okay. In fact, it's very much a Sagnac, or excuse me, a Michelson type interferometer. All right. And what happens is it releases like a little steel ball, right? And it drops it down, I don't know, 8, 10 inches, something like that. And as it's going down, it also starts an atomic clock, which is accurate to, 10 to the 9th places, some ridiculous amount of accuracy, right? And what it does is it as it measures it going down the tube, with this astounding accuracy, it is timing it, and then it is working out mathematically exactly what the rate of acceleration of that ball is. Now, the beautiful thing about this is that the tube that the ball is in a vacuum. So there is no medium, right? There is nothing that, can claim a density or buoyancy variance because there's no medium. This is pure downward acceleration. And notice it always does go down, guys. I mean, no other direction will do that ever. In a vacuum, things will always go down, absolutely no exceptions to that. And notice it always does go down, guys. I mean, no other direction will do that ever. In a vacuum, things will always go down, absolutely no exceptions to that. And notice it always does go down, guys. I mean, no other direction will do that ever. In a vacuum, things will always go down, absolutely no exceptions to that, because there is a bias to that. So what's happening, right, is when you take this gravimeter to different places around the Earth, or even some days on the same places on Earth, you will get different values of acceleration. Well, how is that possible if there is no medium to go through, right? There's no medium or anything like that, when all it's doing is picking up the sheer acceleration, whatever it is that is accelerating that ball from top to bottom, right? It's in a vacuum, nothing changes inside of the instrument itself. And of course, some people will come back with a ridiculous response that, well, nature doesn't have a vacuum in it, therefore that's an invalid test. And it's like, that's ridiculous. And here's why it's ridiculous. Because when we eliminate something, when we put specificity to our tests where we can eliminate certain variables, it actually acts to serve us as a tool, right? If we can get rid of this buoyant and dense, density gradient and just measure purely through the vacuum, the drop rate through the vacuum itself, then we get a pure, unaffected outcome every single time, right? And the interesting thing is around the Earth, things fall at different rates. Now, why would that be? Well, we actually have a great explanation for that, why that would be. And we actually also have some experiments that are going to prove it, okay? But this device right here crushes the relative density disequilibrium argument, absolutely crushes it, because there is nothing that you can claim here where anything is going from a less dense to more dense medium. It's in a vacuum, it's all the same medium, and yet there is still a downward acceleration, and that downward acceleration does change from place to place, and even sometimes in the same place. Right.
So Bob, does that, at the risk of sounding stupid, and I'm feeling pretty stupid at the moment, but does when you say everything goes down, do you mean gases as well inside this device?
Even gases will, yes, because if you have helium, and helium is the least dense gas we know, right? Mm-hmm. But even helium has to be, if it's going to rise, it has to float up on something, right? Well, if there's nothing to float up on, then what's it going to do? It's going to sit on the bottom.
Sit on the bottom. That's really interesting. I didn't know that. And do they have these sort of devices, bigger devices than these? That, because I'm just thinking about Zach's balls.
Okay, I'm going to be really concise here to make this quick and painful. So, on screen we've got Bob's words, and basically Bob's an idiot. Bob says no medium, always goes down, no other direction, ever, no exceptions. Yeah, that's because all objects of mass that you're going to put into the vacuum, Bob, they're all great. They're all more dense than the medium. The medium's now a zero volume, right? A zero density, right? But you're putting something in there that's got something other than zero. Well, what do you think is going to happen? This supports relative density, Bob, because your medium's now a zero value or very close to zero. The only way this doesn't work, Bob, and if you can prove this would disprove relative density, is if you shone a laser in there, and then because the laser is then equal to the medium that's in there, or less dense than the medium in there, because light is a massless particle according to current science. What should happen is the medium should displace light all the way to the top, because you're never going to get a perfect vacuum, but light is supposed to be a massless particle. So you should be able to shine a laser and it would rise to the top and pool at the top, because light is massless, whereas the vacuum can never be perfect. So if what you're saying is correct, you just fire a laser into there and watch the laser stay and pool at the top, because that's what should happen if you're correct. But because you're not correct and you're putting an object of mass in there, it's always going to displace that zero value of medium. And he says there are no other direction ever, no exceptions. Well, we're going to come to Savage in a minute, who talks about gas. So if you put a gas molecule in there and it's going to bounce around continuously, it's going to do two key things that you just don't get. It's going to A, conserve its momentum, and B, collide with elastic collisions against the walls of the container, the vacuum container. So the gas, if you were to just put one gas molecule in there, it would just continuously bounce around. We'll come to the gas in a minute. We're going to use bromine as an example to see whether Bob's correct or not. So we'll come back to that in a minute. Then he says this device absolutely crushes relative density. Nothing that you can claim here in a vacuum, all the same medium, same downwards acceleration. Yeah, we're going to deal with that with the bromine. The bromine debunks your claim, Bob. I'll just deal with this last bit first because it's quick. Don't go all gas, go down, go boom boom on us, Bob. This is Bob's paradox, because if Bob creates a current with the negatively charged Earth, then he has to explain, or he has to address, the gas molecules going down in a vacuum chamber, which they don't do. Now, because gas molecules do not go down in a vacuum chamber, they don't pool on the floor, that means that not only does it debunk his claim that there's a flow, it means that Bob doesn't understand that gas molecules behave differently to solids. So because gas molecules will fill the available volume, we've all seen the clip, it means that Bob's perception of the downwards bias is not only debunked, but this proves that Bob's wrong. Bob shouldn't be arguing that gas molecules go down, go boom boom, but because he was put on the spot by Savage, probably and presumably innocently by Savage's perspective, it means that Bob's position now has totally become untenable, because the bromine test proves that it doesn't pool in the bottom like Bob needs it to. So, unexpectedly, Savage, I'm sure you didn't do it intentionally, you show Bob's argument to be absurd, because bromine in a vacuum doesn't pool the way Bob thinks it does. And Bob thinks that because there is only ever a downward direction to this, well, he can prove that with light. So Bob, get a little bit of a laser or a light source and shine it into the vacuum chamber, and because you'd never get a perfect vacuum, so you'd never get like what they call neutral buoyancy, the light is always lighter than the medium, and even though the medium's getting close to having no mass in it because it's almost a vacuum, it's never got nothing in it, has it? So the light should always go to the top, but it doesn't. It bounces around in all directions and we can see through it. A vacuum's not a black hole, is it? It's not absorbing all the light. So this debunks the idea that you're claiming that it's always down, because it's not, because light is massless, and it debunks your claim. So let's have a little look at the bromine example. We've all seen the bromine example. This old clip shows the guy that opens the valve, and he's got all the bromine in one side, and if Bob's position was correct, it wouldn't fill the available volume. Now notice what happens when the tap's opened. It divides the amount of gas in there in half, because you're doubling the volume. Notice the change in the density of the or the opacity of the gas before and after. It's more concentrated on one side. It's now half of its opacity after the tap's opened, and that proves that the volume has doubled. But notice how it's not pooling. It's bouncing evenly off all the container walls. That's why it's a uniform. It's basically homogeneous in that sense. It technically isn't, but it's acting like it was homogeneous in the sense that it's the same all the way through. That's because all the molecules are bouncing off each other and bouncing off the thing evenly, because it's one gas. That's what it does. That's the way gas behaves. Bob, you've got everything wrong here. Your position is untenable. Now listen, I can admit and accept that I didn't really get your position correct when I applied the Faraday cage. And that was based on my own ignorance, because I didn't realise that you weren't talking about electromagnetism at the time. I thought you were talking about incoherent dielectric magnetism, because I didn't know what your current position was, and I apologise, I got it wrong. However, you're getting everything wrong. You've put a negative charge to Earth that's wrong, demonstrably wrong, probably because you don't realise the plugs thing that we have in England, which is an ignorant position, but I was ignorant, and I'm going to say that you're ignorant too. And then you're also saying that vacuum chambers debunk relative density, and think that gas molecules go down, go boom boom, and they don't. They collide with the walls of the container with elastic collisions, and they don't have any reduction in momentum. They conserve momentum. It's time to make some concessions, Bob. Your whole show last night fails on 3 fundamental parts. You created a model and reified. You negatively charged the Earth. And you said vacuum chambers are destroying relative density, but they prove it. Gas molecules don't go down, go boom boom, Bob. It's time to make some concessions, buddy. Be a man and admit you got these things wrong.